This is week 7 UAS hard kill, and I'm Ethan.
Don.
Sarah. Lindsay.
Azim.
And so we'd like to paint a picture for you that really highlights the pain points in our problem statement. So, imagine yourself, you're John Smith and you're a soldier and you're patrolling through the streets in a city in the Middle East, and a drone is spotted overhead and you detect that it's a threat. So one of your nearest men pulls out a rocket launcher, shoots it, misses it completely because it's not as accurate as it could be. And so the drone continues to fly closer and closer to these buildings that are above you. And so you have no choice but to use your rifle to start shooting at the drone. And as you're shooting at it, you're missing all around it, and unfortunately you hit the civilian that's standing on top of one of these buildings and miss the drone completely. So these are just some problems that could arise when trying to take down drones in a similar situation.
So this last week, we really tried to start on, in terms of the start of the week, we tried to focus on getting more information with EMTs, but we were having a little difficulty trying to connect with some of the companies there. So we left that for pending for now, and we're going to continue trying to find other people to investigate with. But the big pivot points and areas that we made changes from last week were that we were going to use BirdNet instead of Graphene. So one of the big fears that we had last week was, before we made that pivot, was we weren't sure if BirdNet was going to be strong enough to actually take down the drone mid-flight. We were going to originally do a test where we were going to launch some netting at some drones, but we found out through interviews that we didn't actually need to do this, so we kind of confirmed that BirdNet would be strong enough to take it down. So we accepted that hypothesis. And then the other thing that we brought up last week was we weren't sure that the propellant in the bullet would explode based off of the M203 when it gets launched out of there. We weren't sure that since it uses a firing pin in the grenade launcher, we didn't want it to explode in the soldier's face. And this one we've accepted, and we found out that the M203 already uses propellant to actually deploy grenades from its tubing. So we also accepted that hypothesis as well. And then in terms of discovery methods for next week, we're going to continue discussing feasibility of our MVP because there's a lot of subsystems working together. So we want to make sure that what we're saying can actually be done. And then we want to also focus on the navigation system. So we need to understand how the bullet is actually going to be moving based off of the information that's receiving from the sensor to help track down the drone. And then we also have exploring the EMP options instead of physical deployment. And this is something that we want to make a higher priority for this next week.
So there are a couple of things that I want to highlight on our mission model canvas that changed from last week, specifically in our mission achievement. We were unsure about improving the accuracy or having reliable accuracy in our products because so many sensors are inadequate, even radio frequency scanners, which are considered to be really one of the best options. We have decided to use computer imaging, which will give us more reliable accuracy. So as far as our mission achievement, we hope to have between 90 and 99% accuracy, and we're still determining what would be a feasible amount of accuracy. Additionally, something I wanted to highlight because some people were confused last week, when we mentioned that there would only be a couple of M203s per unit, that wouldn't be a problem because you're not going to have a swarm of drones with every person needing to defend themselves. But if an M203 is represented in each unit, then the unit will be protected by the one person who's able to defend them. So those are a couple of things I wanted to highlight in our mission model canvas. Additionally, we are honing in on our infantry soldier. People that are currently in the military are not allowed to talk about this problem, so we are getting closer and closer to fully understanding it despite these obstacles, and we have interviews set up for next week with people who have actually encountered drones in the field, and so this is going to be really revolutionary for us.
All right, so not much has changed in our VPC. However, the one chink in our prototype's armor was that we had no way to track the target in real time. So we think we've kind of solved that problem this week, and that's what's highlighted in the game created section. So with the integration of an IMU, we believe we can do that, and Lindsay's going to talk about that later on.
All right, so our customer workflow is still consistent. Enlisted soldier, you have to, once an enemy drone is detected, you need to analyze the situation. Is it an emergency, or is there another action that they can take, soft kill or hard kill situation? So our Gidus bullet is coming along slowly, but we're still using our military-grade rifle and then the M203 attachment. It's going to be shot using propellant. It's going to be a two-part bullet system. The first part of it is going to basically be where the propellant explodes. Once it gets into the sky, it'll release that part, and then the second part of the bullet will continue on, and that part basically kind of protects the netting from burning up from the propellant. Inside this bullet, we're going to have a drone sensing unit, guided propulsion, and the sensor is also going to be able to deploy the net. So once it's in range of a drone, it's going to say, okay, open up the second part of the bullet and deploy this net. For the sensor and for the tracker, we're thinking about using a micro PNT, which is basically something that does absolute real time for navigation and timing. It does like a calculation, and then the IMU also contributes to the micro PNT. And then Sarah's going to talk about the Fender gyroscope.
So we made some really, really exciting improvements and some great aha moments this week as far as the drone navigation and the netting. First of all, since I'm holding this, I'll show you. This is just a rough prototype of our netting. This is trout netting. It's really strong. It would definitely interfere with propellers and keep the drone from working. And it has weights attached to the bottom that will help it as it's flying through the air, not to let the friction of the air keep it from reaching its target. The guided propulsion is a very exciting improvement thing that we are developing. We hope to help, because the drone can see its target, but it still has to change direction to see it. So we're anticipating using either Fenders or a gyroscope to reach that, and we'll expand on that in future weeks. That's it.
Great job, guys. Questions and feedback? First of all, I think you did an exceptional job at being able to hear what your changes were. So scroll back in your slides just a little bit, just point it out. So keep going right here, but it's still on other slides. Like, it's just easy for me to glance at that, and you also reiterated it in your presentation, made it super clear what's new. And not only did you do that, but you talked about why you did that and how you did that based on the interview stuff you got today. I thought that was completely exceptional. Great job for that.
Go back to your hypothesis page.
There we go.
Just a second. Or third.
Please.
So the EMP, how would you use that? Because most of them require a massive amount of energy to create, and they disperse very quickly. So like if you detonated it right here, about 3 feet away, half of the energy would be gone.
So that's a very good question. We kind of wanted to talk to a subject matter expert, because I actually had an interview with somebody, and he actually brought up the idea that, and he believed that if you use a small enough EMP, you can kind of isolate a small region. And I wasn't sure how that specifically works, so I wanted to talk to a subject matter expert before we made that pivot.
That's what it's so
I just wanted to, again, last week you guys, like you had made this remark too, that seemed like something was stymieing you, you weren't hitting obstacles, a little bit of wall. And it's just like an explosion when you've now gone over that obstacle and through that obstacle. Last week, I don't know that you thought you could, but it's just been an explosion. It's just very beautiful, really, to see how you guys have just gone through it.
What happened?
They just accepted it and moved on and said, I'm going to do it.
A lot of research.
Force of will.
Force of will.
Yes.
Good. Well, I'm going to pick on one small detail. I've heard the word accuracy. Maybe I'm the only one in this room that had a feeling that I seem to be talking about two things at one time. So you're talking about reliability, and then you talk about accuracy. I heard the number 90% and above. Is that the accuracy of the one-time attempt?
When I'm referring to accuracy, I'm referring to accuracy of the sensor, which would be using computer imaging, as far as reliable, accurate detection of the drone, as opposed to, I'm sorry, what? Well, takedown would be reliant on it detecting the drone, but that particular point is being able to detect the drone as opposed to just getting distracted by something else and going in another direction, which would be a huge problem.
So if I repetitively doing this
Uh-huh.
over and over again, is there an indicator, maybe quantifiable, to measure that?
If I understand your question.
In a given period of time, say 8 hours.
Yeah.
And then today, the next day, you do another 8 hours, and the third day, and the fourth day. So as you are doing this over and over again repetitively,
Yeah.
every single time you're doing it, the accuracy will be reliable all the time. I mean, it'll be always 90% plus.
9 out of 10 times it would detect the drone. Does that answer your question?
Within what areas? How close do you have to be for it to detect it 90%?
And that, I guess, would probably depend on more of like the sensor technology, and again, I don't know, we've gotten an idea of the sensor technology, but I don't have the expertise.
Wouldn't you not, they wouldn't know that.
We wouldn't know
Yeah.
that, like, we would have to go down to like know the
I
specific
don't have
component.
that expertise done.
So the rating of the sensor will be based on a circular probable of the drone. So if you're 30 meters away when the drone when the bullet passes the drone, is not going to be as reliable if you're 5 meters away when the bullet passes the drone.
Right.
And the ability of the bullet to correct its flight path if it's 30 meters away is also going to be reduced, right? So those are the things that he's talking. So if you always fire it 5 meters away from the drone, you should be 90% reliable. But there's variability in targeting, and because you got to, when you're firing from the 203, you got to kind of get close. I can't. If the drone's over there and I shoot over here, I guarantee you're not going to be 90% reliable, right? You got to get it close. So what's the?
Sorry. I think one part that we missed before we were done is we have to have a processor that's going to go, like that's basically going to contribute to the entire bullet. And the processor is basically going to calculate accuracy, timing, velocity, position of the drone, and things like that. And that ties it all back to accuracy and reliability of when the drone or when the net is going to be deployed and things like that.
We'll talk.
Yeah.
All right, your feedback is finished. Great job, guys. 1, 2, 3.